Hi, my name is Abby Kivett, and this is my Dsari project for BBE 2201. For background, I live in Middlebrook Hall, which is a residence hall at the University of Minnesota, and it was built in 1969. I live in a double room with one other roommate, and our room is about 179 square feet, and I have no access to my energy bill, so all the data in my energy context is from online resources. For the background of residential energy consumption in the United States, as of 2020, the residential usage accounted for 22.4% of the United States energy consumption, and residential electricity end usage was about 1,465 terawatt hours out of 3,717.6 terawatt hours from all energy sectors in 2020. For energy context, according to DSO Electric, the average college building consumes about 18.94 kilowatt hours per foot squared of electricity and spends $1.95 per foot squared annually. I multiplied 18.9 by the square footage of my room to obtain the value of 3,390 kilowatt hours per year, and by doing some unit conversions, this came out to be about 9.28 kilowatt hours per day, assuming living there for 12 months. Additionally, this pie chart shows the electricity end use for different appliances for residential colleges in the Midwest. As you can see, ventilation, miscellaneous, and lighting account for the highest energy uses. And some watts used by common appliances, according to the University of Pennsylvania. There are values for a fridge, a coffee maker, and a microwave, which are all appliances that I measured in this audit. And I will be comparing these values and the percentages from the pie chart to those I obtained at the end of this audit. So what did I do? I measured 8 devices with my kilowatt meter. I made a time log of what I used and when, and how I calculated depend on the type of device, constant or variable power, or the direct wattage from my light bulb. My 6 constant power devices were my LED lights, my fan, Keurig, microwave, hair straightener, and air humidifier, and the appliances with 2 pictures are showing the phantom power. So how I calculated for my constant power devices, I set the meter to measure watts and determined if there was phantom power before I turned the device on. And then I waited for 1 minute and recorded the watts. Then I multiplied the watts on by the average time used per week for each device, and I repeated the method if there were watts off. And then I added these two numbers together to find watt hours per day. An example is with my microwave. The phantom power was 0.5 watts. The power when on was 1164 watts. I multiplied these by the average hours that I used them per day and the average hours that they were off. And I added these two values together to get a total of 40.41 watt hours per day. For my light, it is also a constant power device, but I had to record the direct wattage from the Target website because my light bulb's not in screw, it's built into the lamp. And for my time log, I multiplied the watts by the average hours I use it per day. And my sample calculation was 4.5 watts times 3.7 hours a day on, which equaled 16.65 watt hours per day. For my variable power device, which was my mini fridge, this power cycles throughout the day, so I had to make the settings record kilowatt hours. And I plugged in the meter for 24 hours exactly. And then the value I obtained was 0.534 kilowatt hours, and I multiplied that by 1,000 to get watt hours, which is the unit conversion from kilowatt hours to watt hours. And since it's on 24 hours a day, the total watt hours per day would be 534. This is my 1 week time log, and the time is in hours. Some notes is that sometimes I would leave the fan on all night and all day, so this accounts for the large values on Monday and Tuesday. And my roommate and I share various appliances, so I had her write in her notes app every time that she used them, and then I implemented these into my calculations for this table. My energy summary table, as you can see, my highest energy users were my fridge and my fan, which are not very surprising because I use these the most. And my kilowatt hours per month accounted to be 37.85 kilowatt hours. For comparison, an average college space of my size consumes about 282 kilowatt hours per month, and my value was 37.85 kilowatt hours per month. And looking back at the pie chart from the energy context, according to them, about 6% of electricity end use went to refrigeration in Midwest college buildings, and mine was 42%. And for lighting, their value was 18%, and mine was 0.077%. So some reasons for these differences: number one, I was unable to measure the heater or the AC, which would highly contribute to the total kilowatt hours of electricity per month. Also, my roommate has her own lights and electronics that I don't use and didn't measure, so those contribute to our total kilowatt hours. And finally, the data obtained from the energy context was for all college buildings. It was not dorm specific. I have to take that into account the lack of appliances in my room compared to the appliances in all college spaces, and I also don't really have high energy use appliances such as a TV or an Xbox, so that also contributes to my total kilowatt hours per month. And also looking back at the table from before, as you can see, my watt values were not very different than the University of Pennsylvania's, and also my fridge is smaller, so that makes sense. So I think that this goes to show that my difference in kilowatt hours per month does not have to do with the appliances themselves, more the appliances that I didn't measure. So some things that I will do to improve is that I will start to turn my fan and lamp off when not in the room or right when I wake up before class, because I tended to leave them on all day when I wasn't even using them. And I'll also start to use natural lighting during the day, because sometimes I would have my lamp on when I didn't need it. And in the future, I plan on buying Energy Star appliances or LED light bulbs when I move into my apartment in order to just conserve more energy and save more money. Here are my references, and thank you very much for listening.